So in this video, now we're going to look and see whether an equation is a linear function or not. And so we have some guidelines to determine whether an equation is linear or not. So to be a linear equation, the following must be true. X and y are not multiplied together. So basically that means I can't have an x and y right next to each other like that. X and y have exponents of 1. So that means I can't have 2 be an exponent, 3, any other number. It has to be 1. And just so you know, if you just see x by itself, there's really an imaginary 1 with it. So those two are the same thing. X and y are not in the exponent. So I can't have like 2 to the x. That's not allowed. X and y are not in the denominator. So basically I couldn't have like a 2 over x here. And then lastly, x and y are not in a square root. So you couldn't have the square root of 3x. So when we're looking at an equation to determine whether it's linear or not, we're going to follow through that checklist and make sure that it doesn't go against anything on there. Okay, so let's look at some examples. So looking at that first one, I have y equals 3.8. I want to determine whether that's linear or not. Well, x is not in there, which is fine. So y is just really a constant. So looking up here, x and y are not multiplied together. X isn't even there. X and y have exponents of 1. Yep. They're not in the exponent, they're not in the denominator, and they're not in the square root. So this one is in fact linear. So anytime you have just y equals some number, or if I had x equals some number, that will be linear. Okay, next one, y equals square root of x. Well, I already have up here in this last one, the x and y are not in the square root, so this one's nonlinear. Y equals 3 to the x. Again, I have x in the exponent. That's not allowed, so that is nonlinear. Okay, next one, I have y equals 2 over x, so x is in the denominator, which again, that's not allowed for it to be linear, so that is nonlinear. Okay, now this one's a little bit tricky. I have some parentheses here, and so maybe pretty tempting to at first say, oh, that's not linear, it looks different. Well, I need to be careful here, so I'm going to go ahead and distribute the 6. So I have 6 times x, which is 6x, 6 times negative 1, which is negative 6. And now I'm going to run through my checklist. Are x and y multiplied together? No. Is x in the exponent or y in the exponent? No. Do they have exponents of 1? Yes. Are x and y in the denominator? No. And is there a square root that x and y are in? No. So it passed all of my checklists. That means this one is in fact linear. Okay, now looking at this one, I have x squared minus y equals 0. So anytime I see an exponent in there, I want to be kind of leery about it. And so this one is in fact nonlinear because x has an exponent of other than 1. And so that means that this one is nonlinear. Okay, that's it for this video. You can go ahead and move on to the next one where we're talking about representations of functions.